So we're going to discuss the third question. The third one. A power station burns waste materials from farm crops to generate electricity. State and explain whether this process is renewable. So, yeah, the statement is, why do you think it is not renewable, Rabia?
Because waste materials are burned in the process, so they're destroyed, so they can't be used again.
Yeah, but the station burns waste material to do what?
Generate
Electricity. And okay, it is renewable, right? Because if you burn, it will burn. But if you let it for some time, like let's say you are letting it to be cooled down for about 3 to 4 days, you can use that as for some other purposes. It won't directly cope up with this. And also, when it was farm crops, it will not finish for after a time, right? It is something that continuously grows and it will continuously filling up the farm, the crops. So it is renewable, okay? It is renewable. Correct it.
I was thinking of it like fossil fuels, like you have a lot, but if they're used once.
Oh, yeah. But it is renewable because it can be regrown. So that's why they are thinking that as renewable. And the explanation is crops can be regrown. We didn't write crops can be regrown to replace resources or waste materials do not run out. Waste materials, yeah, do not run out. So it is something that is renewable. Fine, correct it. Okay. Yeah, like you cannot use the burned material, but you can use the new material, right? Like the new waste. So renewable means something that will not end. It will be again and again created. So that's what it means. So yeah, it is renewable. Okay. The power station uses some of its waste thermal energy to heat water for house in a nearby town. Okay. State one problem of using waste energy in this way if the power station is far from the town. Okay, town. Yes, it will lose energy or the thermal energy because it was kind of a far. So while you're taking from from the power station to the town, it will take a bit long. So the energy will be dissipated as other kinds. So that's why. Good. Suggest a way of reducing this problem. What you can do? The mode of transport of the water can be inside a shiny container so that the heat energy is not absorbed or emitted. Okay. Shiny conductor, which is kind of a poor conductor of thermal energy. Or you can make an insulate pipes. You can create insulate pipes, right? So that it will not lose its insulate pipes. Lose its energy whenever if it is traveled or anything. So that's also fine. So for this you will be awarded with 2 marks. Good. Next. State 2 environmental consequences of burning coal to generate electricity. Pollution, of course. What kind of pollution? Air pollution, okay? Air pollution. It's better to write the proper way. Air pollution, or we can have harmful gases, or there can be acid rain. Right? These are some common causes that you can write. And then another consequence, okay, global warming, climatic change, global warming. Okay. Climatic change, global warming. Global warming, or what else? Greenhouse gases, emission of greenhouse gases. What are the greenhouse gases?
Carbon dioxide and methane.
Carbon dioxide. Tell me one more.
Methane.
Sorry?
Methane.
Methane, good. Methane. What is the equation for methane?
I don't know.
Okay, sometimes they would say it is CH4, okay? Carbon and 4 hydrogen. Yeah. Because there is a chance of, like, they can provide you the chemical equations for methane and water for those things sometimes. So it's mainly on chemistry, but since we were discussing under physics, I'm just letting you know. That's it.
Yeah.
Okay. So for this, you got 6 on 6. Good. Oh, no, not 6 on 6, I guess. No, you lost 2
I
more.
lost 2 points.
Yeah, 4 on 6. Good. Perfect. Next question, the fourth one. In terms of the moment of molecules, explain how gas exerts pressure on the walls of its container. Okay. The gas particles are spread apart and move using kinetic energy of particles, in which they collide with each other and the wall of the container to travel. This exerts pressure on the wall. As the more gas particles collide with each other, the more pressure increases. Along this, temperature increases, the movement of particles increases, so does the pressure. Okay, the thing is, you get misdirected from the question. They have clearly asked you to explain in terms of moment of molecules. But in your answer, there is not even a single word of moment, or even moment. Did you observe? What you did, you just explained using the pressure. But they are asking how the pressure is exerted. Explain it in terms of momentum of molecules. Did you understand? Yeah, for the first thing, I can give you 1 mark because that's the introduction. But thereafter, you have to mention the momentum. I'll tell you how to write it. First, what happens? The molecules strike walls. Okay, it will strike the walls. So the momentum of molecules changes. So momentum of molecules changes. If it is changing, like momentum means mass into velocity, right? If it is striking the walls, the velocity changes. So the momentum changes. So due to the rate of change of momentum, what is rate of change of momentum?
Force.
Good, force. So the force will be changed. Okay. So the rate of change of momentum is force, and it changes. Now we are coming to the point. Due to the force changing, what will change? The pressure, right? Because pressure means forces by area. Now the area and the forces are changing because it was striking in a different walls in a different area. So due to that pressure exerted on the walls continuously changing. This is how you have to write as they have asked for
So this one
for this
minus
one.
3 or
-3. It means you will only awarded with 1 mark, okay, for the introduction.
okay.
Like even you don't have to write like this much deep, but somehow your answer should have the words momentum, force, and pressure. That is the keys. So yeah, you can get 1 mark for this. Next, a fixed mass of gas of volume V1 at a pressure P1, it is compressed to a volume V2. Complete the equation for the final pressure of the gas when the gas is compressed at constant temperature. So when it is constant temperature, whose theorem is this?
PV equals constant.
Yes, the PV is equals to constant. So P1 V1 is equal to P2 V2. If we just change it, this is how it will be. P1 V1 divided by V2. Okay, good. So yeah, this is how they have allocated the marks. Did you observe? They have given 2. But you have written only 1, right? How can they give you 2 marks for a 1 written?
I thought it was like a V1 times P1 and it could be divided by V2.
Yeah, so first you have to mention the actual equation as well. P1 into V1 is equals to V2 P2 into V2. Or the other way, anything is fine. But you have to mention this to score the another 1 mark.
Okay.
So there's only 1. Okay, next. State and explain how the final pressure compares with the P2 when the temperature of the gas increases during compression. Explain how the final pressure compares with P2 when the temperature of gas increases during compression. When the temperature increases, what will happen to the pressure?
When the temperature increases, the pressure and volume will remain constant.
No, how can it be? They haven't said the number of molecules is constant. If the temperature increases, the pressure will also increase, right? Because, yeah, they are compressing. So the volume decreases, the pressure increases, so that the temperature will also increase. So they are not equivalent. It will be greater, okay?
Yeah.
Good.
So, temperature.
Greater. So the molecules move faster and have greater kinetic energy and greater momentum. So the more frequent collisions will happen. So this is how your answer has to be. Molecules move with greater kinetic energy.
Final pressure. Okay, I got thrown off by the I was thinking like pressure, volume, constant. They were saying like how are they constant?
Oh, fine. Now you have got it right.
Yeah.
Greater kinetic energy and
which increases the pressure.
more frequent collision. So it was like frequently hitting on the wall, definitely the pressure would increase, right? It was trying to come out. Due to the increased pressure, the molecules get heated up. They are running fast here and there. So they will just want to come out, but there is no space to come out. So they are hitting the wall with more frequent collision and high greater kinetic energy. Then obviously the pressure would increase. That's all. Okay. More frequent collision, so pressure increases. Okay, so that's how it is. So for this, I can give you 1, 2. Oh, okay. Did you get 2 out of 9? Is it? Okay, okay, fine. But we have learned so many. We have learned so many by just giving.
I think also the order paper, I'm like getting confused on the words.
Yeah, it's due to the wordings. That's how they will play. Then how can they? So they just play with the words, make you confused, end up with like this. That's fine. We have learned so many. So from the next paper, from the next question, you will be more aware. And usually these pressure, volume things a bit confusing, but like if you just understood the question once, you'll definitely get it correct. Yeah. That's how it is. Manageable. Cool. So yeah, that's it. That's about this. Now let's go for the question number 5 and 6.